Here we have a SAT math problem. Okay, let's cover the question. A quadratic function models the height in feet of an object above the ground in terms of time in seconds after the object is launched off an elevated surface. The model indicates that at a time of 9 seconds, the object is 294 feet above the ground. At a time of 13 seconds, the object is 310 feet above the ground. If the object was at a height of 24 feet when it was launched, what is the height in feet of the object above ground 18 seconds after being launched? Since a quadratic function models the height of the object, we can write the quadratic function in standard form, that is y equals to ax square plus bx plus c for the given scenario. Here in this quadratic function, x represents the time in seconds and y represents the height of the object in feet. And there is an information, the object was at a height of 24 feet when it was launched. When the object was launched, the time is 0, that is x equals to 0, and at the time the height is 24 feet, that is y equals to 24. So clearly we have y-intercept of the quadratic function, that is 0, 24. When we write a quadratic function in standard form, that is like this one, the constant over here represents the y-coordinate at the y-intercept. The y-coordinate at the y-intercept is 24. That is the initial height of the object. We can plug in 24 for the constancy over here. Then the function will become y equals to ax square positive bx or positive 24. Okay, now my aim is to get the values of the two constants a and b. Once I get the values of these two constants, the quadratic function over here will be complete, and we can plug in this 18 for x and get the value of y to get the height reached by the object 18 seconds after being launched. Okay, how do we have to get the values of the two constants a and b? We can use the given information. That is, the model indicates that at a time of 9 seconds, the object is 294 feet above. That is, when x equals to 9, y equals to 294. Okay, let me plug in this stuff over here. Y equals to 294 and x equals to 9. That is a times 9 square positive b times 9 positive 24. We can subtract 24 from both sides of this equation. Then this positive 24 negative 24 will cancel out. When we simplify this one, we get 270, and the value of 9 square is 81. 81 times a is 81 a, positive 9 times b is 9b. Okay, here when I consider this 270, this 81, this 9, everything is a multiple of 9. So to simplify this equation further, let's divide each term of this equation by 9. Let me do it. Okay, here when I divide 270 by 9, I am getting 30, and when I divide this 81 by 9, I am getting 9, that is 9a, and here 9 will cancel, I am getting b. Okay, here I got a linear equation in terms of the two unknowns a and b. Let me consider this is equation number 1. Now let's consider the information we have over here. That is, at a time of 13 seconds, the object is 310 feet above the ground. That is, when x equals to 13, y equals to 310. Let me plug in this information into the quadratic function over here. That is, 310 equals to a times 13 square positive b times 13 positive 24. Okay, let me subtract 24 from both sides of this equation. Okay, then positive 24, negative 24 will cancel out. When I subtract 24 from this 310, I am getting 286 equals to the value of 13 square is 169, that is 169a positive 13b. Okay, when we consider this number 286, 169, 13, everything is a multiple of 13. Okay, now let me divide each term of this equation by 13. Okay, now let me divide 286 by 13. Let me do it. I'm getting 22. When I divide 286 by 13, I'm getting 22. And when I divide 169 by 13, I'm getting 13, that is 13a. And this 13 will cancel. I'm getting positive b. Let me consider this is equation number 2. Now let's solve the system of two linear equations over here for a and b. Okay, when I subtract the two equations, I'll be able to eliminate b. So let me subtract the first equation from the second equation. Okay, now let me write the second equation as it is. That is 22 equals to 13a positive b. Since we have a negative sign in front of the first equation, we have to multiply all the terms in the first equation by negative sign. Then this 30 will become negative 30, and this 9a will become negative 9a, and this positive b will become negative b. Okay, here this positive b, negative b will cancel out. When I simplify this positive 22 and negative 30, it will become a negative 8. And when I simplify this positive 13a and negative 9a, I am getting a positive 4a. Okay, now let me divide both sides of this equation by 4. Then this 4 will cancel out. I am getting negative 2 equals to a. Okay, here I got the value of a, that is negative 2. Let's plug in a equals to negative 2 into the first equation or into the second equation to get the value of b. Okay, now let me plug in a equals to negative 2 into the first equation, that is 30 equals to 9 times a. For a we can plug in negative 2, positive b. Okay, 30 equals to 9 times negative 2 is negative 18, positive b. Let me add 18 to both sides of this equation. Then this negative 18 positive 18 will cancel out. When I simplify this, I am getting 48. On the right side, we get b. Okay, here I got the values of a and b. A equals to negative 2 and b equals to 48. So now what we have to do is we have to plug in the values of a and b into the quadratic function we have over here. Okay, now let me erase all the stuff and continue the problem. Okay, y equals to, for a we have to plug in negative 2, that is negative 2x square, positive. For b we have to plug in 48, that is 48x, and we have the value of c, that is 24. Okay, now the quadratic function which models the height of the object is complete, and we have to find height of the object 18 seconds after being launched. We know that in this quadratic function, y represents the height of the object and x represents the time in seconds. Okay, now let's plug in this 18 for x and evaluate the value of y, which gives the height of the object after 18 seconds. Okay, now let me do it. It is y equals to negative 2 times 18 square, positive 48 times 18, positive 24. Okay, y equals to negative 2 times, we know that the value of 18 square is 324, positive. Okay, let me calculate 48 times 18, that is 864, positive 24. Y equals to, when I multiply this negative 2 and 324, I am getting a negative 648. Now we can combine this positive 864 and positive 24, then I am getting positive 888. Okay, y equals to, when I combine this negative value and positive value, I am getting 240. Okay, here I got the value of y when x equals to 18. That is the height of the object 18 seconds after being launched, that is 240 feet. We find this 240 in answer choice D. The correct answer choice for this question is D.